Now we look at example 3, the derivative of a radical function by using the definition of derivative. So this question involving radical function. So given fx is equals to square root of 2x minus 1. So the question is, find f prime x again by using the definition of derivative. So we only use the formula that when the question mentioned about the definition of derivative, means that if I try to find f prime x, so the formula that I'm going to use is limit when h approaches 0 for fx plus h minus fx over h. So why I'm going to use this formula? Because the question mentioned about the definition of derivative. So I need to use this formula. So against fx, given fx is equals to square root of 2x minus 1. So if fx plus h, suppose here will become square root of 2 in the bracket x plus h minus 1. Now I try to find the derivative f prime x is equals to limit when h approaches 0 for square root of 2x plus h minus 1 minus fx, which is square root of 2x minus 1 over h. So this is how we're going to plug in the formula. And then in order to find this one, because this is limit involving radical, if you still remember, we have three types of limit involving radical. So for this type, we have to rationalize by multiplying conjugate. So what we're going to do is we're going to multiply with the conjugate, which is square root of 2x plus h minus 1. Here is negative, now is positive, square root of 2x minus 1. Same as the denominator, square root of 2x plus h minus 1 plus square root of 2x minus 1. So we try to expand. So here is limit when h approach 0, when square root multiply by square root, we only left the terms inside the radical. So which is 2x plus h minus 1. Same as the here, negative times positive is minus, square root times square root is 2x minus 1 over h in the bracket. So we put a square bracket, which is square root of 2x plus h minus 1 plus square root of 2x minus 1. As we all know, the center or the middle of the terms we will cancel out. So in here, I just multiply front with the front and the back terms in the back term with the back terms. So from here, next, I try to expand. 2 times x, 2x. 2 times h, 2h. Minus 1 minus 2x plus 1 over h in the bracket, square root of 2x plus h minus 1 plus square root of 2x minus 1. So limit when h approach 0. So here again, 2x minus 2x, negative 1 plus 1. So for the numerator, we have 2h over h in the bracket, square root of 2x plus h minus 1 plus square root of 2x minus 1. Next, we can cancel out the h. So here we have limit when h approach 0, 2 over square root of 2x plus h minus 1 plus square root of 2x minus 1. So next I will substitute the value the h with the value of 0. So 2 square root over square root of 2x plus h. H we substitute with 0. So minus 1 plus square root of 2x minus 1. So when I try to simplify, here I have 2 over square root of 2x, x plus 0 is x, so 2x minus 1 plus square root of 2x minus 1. Square root of 2x minus 1 plus square root of 2x minus 1. So this part, I will have 2 over, if square root of 2x minus 1 plus square root of 2x minus 1 means that we have 2 square root of 2x minus 1. So means that this one plus this one means that we have 2 square root. So after that, I try to simplify. So here, I have 1. And finally, the answer will be 1 over square root of 2x minus 1. So for question that involving radical function, we need to multiply with the conjugate.